So today we're going to do volume. Now volume is space in 3 dimensions. How much space do I occupy in 3 dimensions? If I have 1 dimension, that's called length. The length of a line or anything like that. And let's pick a set of units, let's say meters. If I have 2 dimensions, then I have area. Right? So I might have 2 meters. But if I have area now, I have 2 meters by 2 meters. So I have across and then up, and what that does is it creates a square. Easy. Now if I have 3 dimensions, now that is volume. And what that does is now I have width, I have height, length, height, and also width. So let's go and do this. And that's going to be 2 meters. This one up here is going to be 2 meters. Now that is going to give me a square, but this one here is going to be p cubed. And the volume of this would be 2 meters times 2 meters times 2 meters. 2 times 2 times 2 is 8. Meter times meter times meter is meters cubed. And that's why it's called meter cubed. Because if you imagine the length of a meter, imagine a cube, like a box you've got something in. How many of those would fill in, like say, this room here? Now, we've done area and we've done length. Now we're going to do volumes, right? Now remember, volumes is in 3-dimensional space. So, what I want to do here is I want to think about the volume of a prism. Now, a prism is something where the sides rise vertically. So if I have, let's say, a rectangle, like that, and then it rises up like that, like a fish tank. I hate drawing them that way. So I'm going to draw it again. I'll show you how I always draw prisms. They look like this. Rectangle, which is easy to draw. And then off center, you do another rectangle, which is also easy to draw. And then you just join sides, and then you have your fish tank. Much easier. Now, there are many, many ways and there are many formulas for volume. I think the easiest one is to think of the base, the floor, whatever you want to call it, right? And that is a rectangle. This is the length this is the width, and this here is the height. I want you to think as the volume of any prism. This is the formula for it. The area of the base times the height. Now the base is actually a rectangle. So the area of that is just going to be the length, that's an L, times the width. That would be the area of the base. And then times the height. And the answer is always, whatever the units are, cubed. Let's see if I can make that 3 better. Units cubed. Okay? Always, 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 always. Units cubed. Length is centimeters. Area is centimeters squared. Volume is centimeters cubed. So, let's do a problem. Find the volume of the A cube. Now a cube is a square. Inside a square, like that. These are all the same. They're all the same. Let's say that's 10 centimeters. Now the volume will be the area of the base. Now that's 10. That's a square. That base is a square. 10 by 10. So that's the area of the base, 10 centimeters by 10 centimeters, times the height. Well, the height is 10 centimeters. Length times width times height. So the volume will be easily 10 times 10 times 10. If you do that on your calculator, will give you 1,000. Centimeters times centimeters times centimeters will give you centimeters cubed. B. The rectangular prism. Now there's going to be something like that. Oh, so that's 20 meters, that's 2 meters, and the height is 5 meters. That's the base. Though it's a bit wonky, the base is supposed to be a rectangle. That rectangle is length times width, base. So here we go, 20 meters times 2 meters. That's the area of the red, the coloured in, the base, the floor of the fish tank. And then times 5 meters. That would be 200, 20 times 2 times 5. Metre times metre times metre is metre cubed. Now, these are prisms because the sides are vertical, right? What happens though, if I take something that looks like this, okay? That's a right angle triangle, 90 degrees. I'm going to say that's 2. I'm going to say that's 10. And this is what's going to happen. This is going to go up. Oh, that's terrible. It's going to go up. Again, what's wrong with me today? So it's going to go up. It's going to go up. It's going to go up. See how that's a prism? So the base is now a right angle triangle. That's the floor. This is a fish tank, but the floor is a triangle, and it goes up like straight up, and then so you've got a triangular shape, but the sides go vertical. It's here that the volume of this prism is equal to the area of the base times the height. Now let's make the height 25. We'll say centimeters, centimeters, centimeters. Now, in this case here, it's not going to be length times width, is it? Because this was for a rectangle. The base, the floor of the shape was actually a rectangle. The floor of the shape here is actually a triangle. So I have to find the area of this triangle. Now the area of the triangle is half times base times height, or you can do base times height on 2. Same thing. So here we go. Base, height, because it's got to be a right angle triangle, remember? Base times height. Base times height over 2. There we go. Times the height, 25. That's the area of the base. So this bit is here. That's the area of a triangle. And this here is the height. Now when you do that, 2 times 10 is 20, divided by 2 is 10, times 25. So you do that all on your calculator here, times 25. So that'll be 250 centimeters squared. Cubed. Centimeters times centimeters times centimeters. Okay. To see how the base is different? Cool. Anytime you have the sides that rise up vertically, it's a series, it's basically a prism. Okay? And anytime the sides rise up straight from the ground, then it's a prism. And it doesn't matter if it's fallen flat, we would call that C. It doesn't matter if it falls over. Now, let's call this D. Imagine that you had something like this. I'm going to try and do something a little bit different. Imagine if you had something that looked like this. No, it's not going to work. Now that is a trapezium. I'm going to say that's 8, that's 10, and that distance there, the perpendicular height is 5. I'm going to call it meters. But look at what happens here. So imagine that shape on the ground, and then straight from there, the sides rise up. There you go. It's awful. But imagine that that is your fish tank. The bottom, okay, is a trapezium. The floor is a trapezium. And I'm going to tell you that's 15 meters. Massive. See how the sides rise up vertically? But you know what I could have done here? What happens if I make that fall forward and it lands on its side? It could look like this. It could look like that, sort of. So if this fell over or fell forward or something like that, then it could land on this side here. Now, when it's like this, it's obvious that that is the floor. But that's the same shape. So see how the sides rise from this parallel? That's that area there. Where that is 8, that is 10, that height there is 5, and this is 15. Now what you would do here, the volume of a prism would be the area of the base. Now, the base makes sense here, but it has to make sense even if it tips over. That doesn't make this the base. No, it's still this one. Because it's from here that the sides actually rise perpendicular to it. Okay, times the height. Area of the base is a trapezium. So that's A, H, 5, meters times A plus B, 8 meters plus 10 meters, all over 2 times 15 meters. Okay, so that's 16 divided by 2 is 8. It's 40. 40 is 150 is 600. Now sometimes they don't use the area of the base. That's not how they do it. You could hear it, you could see it sometimes. It's called area of the cross section times the height. Now the cross section is anywhere where if you cut, you keep on cutting, you get the same shape. So you can imagine how if I cut along here, I would still get that trapezium. And if I cut here, I would still get that trapezium. That's what I would see. So this is called the cross section. Whereas if I cut this way, I would get different shapes every time, and that would be no good. Now the one thing I will point out is that there is a very special case of a prism. And it has its own particular name, but there's no real reason why it should. It's still a prism. But because it happens so often, and it's a little bit special, it gets its own name. It's called a cylinder. Now remember, the volume of any prism is equal to the area of the base times the height. Now let me draw this one here for you. Okay, there it is. There's my cylinder. I'm going to tell you that the radius is R, height is h. Now, what would be the area of the base? Well, the area of the base is just a circle. Circle looks like this. And the area of a circle is pi r squared. So if the base is a circle with a radius r, then the area of the base is pi times r squared. Yes? And then that's the height. Anything where the sides rise up is called a prism. And the formula for a prism is the area of the base times the height. And so the volume of a cylinder is always this. So, let's do A, B, C, D. I think we're up to E. Let's say that. Let's say that this here is 8 centimeters. This is 12 centimeters in height. You would look at this and you go, that's my cross section, that's my base. Pi times 8 squared times 12, because it's area of the base times the height. Okay? Not sure I have a calculator here with me today. No, I don't. You'll calculate that out, 2 decimal places, and whatever the answer is will be in centimetres cubed, and that's where we are. All right, that's our first go at volumes, just prisms, okay? The prism sides rise vertically, right, at 90 degrees from the base. And if you can do that, the volume is always area of the base times the height. We'll see how you go. I'll send some worksheets out for you.